Good day to all. Today we can discuss about the normalization and standardization techniques in the foundations of data science subject. So what is this normalization and standardization? So these are the fundamental data transformation techniques used in data pre-processing. So the real world data sets contain features measured in vastly different units and scales. For example, house prices in lakhs alongside square footage in thousands of square feet, so like that, when features are used directly in machine learning algorithms, those with larger magnitudes can disproportionately influence the model regardless of their actual predictive importance. So by rescaling features to a common range or distribution, normalization and standardization ensures fair contributions from all features. So these techniques, there are certain techniques we are going to use. So this particular normalization scales and standardizes data set features, brings all features to a similar scale, typically between 0 and 1, and it maps each numeric attribute value. So it falls within a small specified range 0, comma 1. So normally we will be using normalization and Z-score technique, decimal scaling technique. So this prevents large valued attributes from dominating distant calculation in clustering, KNN, or neural networks. So now for normalization techniques, we are going to use key techniques are min-max normalization and Z-score normalization. So in min-max formula is H dash equal to H minus the minimum value divided by maximum minus minimum value, which maps values between 0 and 1. So min-max Z-score, then Z-score using mean and mean absolute deviation, normalization by decimal scaling. So min-max normalization, Z-score using mean and standard deviation, Z-score using mean and mean absolute deviation, normalization by decimal scaling. These are the four normalization techniques. So first is min-max normalization, which is the formula which you have shown, I have shown here. So it rescales all values to the interval 0 and 1. So you are given with example, we can take some four data sets. So in square foot for house 1, 2, 3, 4, and number of bedrooms and the price, everything. So what is the find the minimum and maximum of each feature first. So for the square foot, 1000 is the minimum and maximum 1800. Bedrooms minimum 2 and maximum 5. Price minimum 40 lakhs and maximum 80. So what should be the range? Range should be the difference between the maximum and the minimum value. So range for square foot is 800, for bedroom is 3, and for price is 40 lakhs. And we are going to apply the square foot for normalized formula. So x minus minimum by maximum minus minimum. So what is that x minus minimum? So 1200 minus minimum is 1000 divided by maximum 1800 minus 1000. So what we'll be getting? It is around 0.25. So similarly apply for the next house, the next house, and the next. So all these ranges, see the results. It is the lies between 0 and 1. So minimum value is 0 and maximum value is 1. So output is always bounded within 0 and 1 and preserves the original distribution shape of the data and simple and computationally inexpensive method. This min-max normalization. Next is Z-score normalization. So what is this Z-score normalization? It is actually called as a standard deviation method, also called standardization. It rescales each attribute value so that the resulting data has a mean of 0 and standard deviation of 1. So unlike this min-max normalization, the output is bounded values can be negative or greater than 1. It is the preferred technique when data follows a Gaussian distribution or when the maximum and minimum values of the data are not known in advance. So here x is the original value, mu is the mean of the feature, and sigma is the standard deviation. So it is given with a sample data set of students' height. For 5 students, it is given. If you are going to apply Z-score for this, so mu, first you have to take the average of this height. So the average of the height should be all the values average. So 64 plus 70 plus 72 plus 68 plus 70 divided by 5, it is 70. And standard deviation formula, summation of x minus mu the whole square by n. So we know the value of this mu. So you are calculating that, you will be getting some around sigma is 4. So you'll be calculating x minus mu the x minus mu by sigma. So instead of for that, you are going to calculate all those things. So it is the table represents the height, mean mu, standard deviation, x minus mu calculation for all the values, 70 minus 60, 70 minus 70, 70 minus 72, then 68 minus 70, 70 minus 76. You will be getting some negative and the positive values. And the square value for x minus mu the whole square. So square of the 6 minus 6 is 36, 0, then 4, 4, 36. And for divide by n, you will be getting all these values. Now, we are going to calculate the Z score. Z score is its value is 64 minus mu is 70 average divided by sigma is 4. So, for all the values you'll be calculating, you see this, the output is unbounded and you can and produce negative values and values greater than 1. So, results in a distribution with mean 0 and standard deviation is 1. Less sensitive to outliers than min-max, and it's a preferred for algorithms that assume normally distributed data. Example, linear regression, logistic regression, PCA, principal common analysis, all those things use this Z-score normalization. And next is Z-score. That Z-score normalization by mean absolute deviation method, MAD, mean absolute deviation method. So the formula is x minus mu by, instead of sigma, it is A. What is that? A represents the absolute mean deviation. How it is calculated is 1 by n into summation xi minus mu. So this technique is more robust outliers than standard deviation. And it is not squared value it is going to use. It is going to use absolute deviation. So useful when data contains significant outliers. So in this step, you are going to given with some data x. You are going to calculate x mu for this data. So 200 plus 300 plus 400 plus 600 plus 1000 divided by 5 will give mean value of 500. And how to calculate the MAD, that is average, is x minus mu. So x 200 minus 500 magnitude plus 300 minus 500 magnitude, all those things taken divided by 5, you will be getting around 240. So what is the Z-score formula? X minus mu by A. So x is 200 minus 500 divided by 240. Similarly, calculate for all the values. You will be getting this. Here's what is the major thing is, by calculating this, you can able to uses absolute values, so outliers have a proportional rather than amplified effect. So more robust. That is the major advantage of using this particular method. And this method you will be getting, see this, all the values you are getting as minus 1.25, minus 1.83, 0.42, 0.42, then 2.08. So this is the final answer. And next is normalization by decimal scaling. What is that decimal scaling? Scaling normalizes data by dividing each value by a power of 10. Chosen so that all scaled values fall within the range minus 1 to 1. And this is one of the simplest normalization techniques and is particularly easy to apply when the general magnitude for the data is known. So the formula is Sj by divided by 10 power j, which is less than 1. J is the smallest integer such that your value will be less than 1. So we are going to calculate first. So far you are given with the data set and the maximum value is 1000. So maximum of xi divided by what is the number of digits? 4 digits. So we are going to take j equal to 4. So x dash is x divided by 10 power 4. So x by 10,000. So you are going to apply this formula for all the data sets. You will be getting x by 1000, 0.02, 0.03, 0.04, 0.0. So it all scale values fall between 0 and 1. And this total value. So you identify the maximum absolute value in the data set, count the number of digits in the maximum value to determine j, and divide each value by 10 power j. These are the simple steps. 3 steps. Identify the maximum absolute value in the data set, count the number of digits in the maximum value to determine j, and divide each value by 10 power j. That is, 10, for example, here j is 4, so 10 power 4. So this is your simple another method. So mainly, what we can summarize from this is the min-max method ranges between 0 and 1, and z-score method unbounded is both are unbounded, decimal scaling -1 to 1. So in this, all will be applied for mainly this z-score is applied for PCA linear models, but min-max is applied for KNN neural networks. So for large magnitude data, we can go for decimal scaling. All those methods will be typically useful based on your necessity or based on your data set which you have used. So hope you have understand this. Thank you.